Hello. Today we are going to talk about a paper that deals with county GDP since 1870. In my opinion, this paper handles like three major facts. Um, First is divergence or widening income inequality among states since 1970, and widening income inequality again within states like Rochester versus New York City within New York State. Also, it handles uh, widening income inequality across industry, for example, agriculture, manufacturing, and IT services. So let's look at the divergence of county GDP among states. This figure actually summarizes the idea sufficiently, I guess. This is figure 1 from the paper. It deals with distribution of county GDP per worker. If we look at 1880 and 1970 distribution first, then the difference between the poorest county and the richest county was this much in 1880, but in 1970, the poorest county's GDP and the richest county's GDP differ just this much. So income inequality had been reduced over this time period. If we look at the distribution of 1970 and 2018, we cannot see much difference in this calculation. So this calculation actually used common deflator. However, if we use, or if authors use industry deflator, something else, then we can see the deterioration of income inequality between 1970 and 2018. So the difference between the poorest county GDP and the richest county GDP would be this much from 1970s distribution, and from 2018's distribution. Now let's see, this is the distribution of 2018. So the poorest county's GDP and the richest county's GDP differs this much. So there is widening income inequality across counties' GDP. And that is significant when we use industry deflator. Then why are they so different? So let's take a look, get the difference between common deflator and industry deflator. Here is a two sector or two industry and two state example. Let's consider deflator as just price level index. And we have two industries, two sectors, agriculture and tradable services. For example, IT services like Instagram or Facebook or like ChatGPT, etc. Agriculture is like producing corns. And the price level of agriculture across the US would be like 1 if it is normalized, and the price level for tradable services would be 2. It is like there is monthly subscription for Coins and ChatGPT. The monthly subscription fee for a farmer subscribing Coins, that would be $10 per month, and the ChatGPT's monthly subscription fee is like $20 per month. So that's the relative price for these services or these products. And let's say there are only 2 states in the United States, and state A main industry is agriculture, so they produce corns more than like ChatGPT-like services. In state B, the main industry is like tradable services. So they produce more ChatGPT-like services than corns. Okay. But anyway, in the United States, in the aggregate level, corns are produced as many as 120, and tradable services like ChatGPT-like services are produced as many as 120 in total. Okay. Now let's compute state GDP with common price. Since we assumed that the price level of agriculture is 1 and price level of trader services is 2, and there are the same quantity of outputs for 2 sectors, the common price level across the US, across all the products, would be 1.5. All right, that is 1 plus 2 over 2 sectors, 2 industries. Okay, these are price levels. Then state A's GDP can be calculated by 120. So state A produce 100 corns and 20 ChatGPT-like services. So their output is 120, and so 120 times 1.5 would be 180. Similarly, state B produces 20 corns and 100 ChatGPT-like services. So also the quantity of products would be 120, and state B also produce the same value of GDP, 180. So both states look equally productive in this example. Now, let's use industry-specific prices. So agriculture price or corn's price was 1.0, and tradable services price, the monthly subscription fee for ChatGPT was like 2.0. Then, since state A produces 100 corns, we multiply the price of corns 1.0 to the agriculture output. So the value of agricultural products would be 100 in state A. Then the value of trader services in state A would be 20. That's what what are produced in state A, and the price is 2.0. So total value would be 40. Then GDP with industry adjustment in state A would be 140, 100 plus 40. Now, similarly, we can calculate state B's GDP, and GDP with industry adjustment in state B would be 220. So state B is richer, actually much richer than state A. So that's why we see the difference in the distribution of county-wise GDP when we use common prices and industry prices. So this is similar what we learned from Wednesday's class. We talked about the purchasing power adjustment of GDP across countries. So when we compare the life or living standards between a person in China and a person in the United States, we considered what can $1 actually buy in these countries. That was the purchasing power of $1. So not only we apply the exchange rate, but we also apply the difference of price level in each country. So that's called purchasing power adjustment. And this take the fact into account. I mean, the fact that non-tradable services like haircuts, rents, and foods are cheaper in some places than others because the differences in minimum wages. Now, the common price, our common deflator calculation, and the industry deflator calculation in this paper carries the similar logic. So common deflator ignores sector price differences or industry-wise price differences. And industry deflator actually take that into account, so adjust for these differences. And that's why it shows some countries become richer than their GDP in common prices because they specialize in sectors with higher value and produce more wealth in real terms. Okay. So when we talked about the international comparison of GDP, we just talked about applying only exchange rate would ignore the price level differences in each country. So the price or purchasing power adjustment revealed that poorer countries can often buy more goods and services with a given dollar. So the purchasing power of $1 is stronger in these poorer countries, and the living standards in real terms might be higher than exchange rate comparison suggests. So that was the same logic, in my opinion. So that's what we saw. So this applying the industry-wise price differences, I mean, considering the industry-wise price differences. This is a better picture for the income inequality across counties in the US, and the income inequality uh, among counties or among states becomes wider has become wider since 1970 in the United States. All right. Other than that, let's look at pictures. So let's look at figure 3 of the paper, and this shows GDP per worker decomposition. It is calculated by industry-wise deflator, and the inequality in between 1870 and 1970, the inequality had been reduced over time, and in the late 1800s, the contribution of inequality between states was larger. However, since the 1970s, the income inequality has been rising again, and the contribution of within state inequality becomes more significant in this inequality. All right. Now, this can be also confirmed by GDP per worker across metropolitan and non-metropolitan areas within state. So if we look at this part, before 1970, the dispersion between metropolitan area, which is in purple, and non-metropolitan areas was much larger in the late 1800s, but it became narrower until 1970s. However, since 1970s, the difference becomes wider, right? It can be seen in not only common deflator, but also GDP calculated by industry deflator. So until 1970, the difference became smaller, but it becomes wider since 1970s. Also, there are widening income inequality across industries. Let's look at, again, this picture. Oh, right. And the states which has counties which has higher GDP actually maintain or has higher share of tradable services. So that's what I meant by widening income inequality among industries. So let's look at the share of manufacturing in poor counties and rich counties. So the horizontal axis here shows the poor counties, and if we go to the right, the GDP, county GDP increases. So at the far right end, you have richest county. Okay, that's how this horizontal axis was formed. And in 1870s, if you have higher manufacturing share within the county, you were better off, right? The pattern continued until, it was peaked like in 1930s, and the pattern continued until 1970s. However, since 1970s, even if you have higher manufacturing shares, you, I mean, with in the richest county, the share of manufacturing is actually lower than less rich counties, right? So in 2018, it's again the same. So this is richer county, and this is less rich county, and less rich county shows higher manufacturing shares. Now, if we look at the share of tradable services as industry, then in 2000 and 2018, you see as the county GDP becomes higher, the share of these industries, the industry of all tradable services, increase. 2018, it shows some variation, but also in trend, you see rising share of tradable service industries within rich counties. All right, so that was a short summary of the paper that deals with county GDP in the United States since 1870. Thank you.